So slope, intercept form, point, slope form, doesn't matter which form we have. Both of them represent a linear function. Good with that? Yes. If I have two lines, it simply implies I have two linear functions. Good with that? And when we have two lines, we want to know if that is a point of intersection. For us to have a point of intersection, I'll give you three options. You can pick one. Four options. And I'd like to know if that is a point of intersection. I drop the linear function part because I make the point as in lines, linear functions. So, four options. There's one, both lines have m greater than 0 in the sense positive slope, lines going up. Option B, both lines, linear functions have slope less than 0, lines go down. C, both lines have m equals 0, which means no slope whatsoever. Last one line has m greater than 0, positive slope, another one less than 0. So which one would you pick? Give the answer. What's your name?
Bradley.
Bradley. Go ahead, louder.
D.
D. Why, Bradley?
Because if one has a positive slope or has a negative slope.
One's going this way, another's going that way. Naturally, you form in an X across. Definitely, there is an intersection. If both of them are positive, what can you say about those two lines? They are parallel. If both of them are negative, what can you say about those two lines? Still parallel. If both lines have m equals 0, great question.
They're the same line.
They are the same line, not necessarily, but same lines. Fine. Yes. M equals 0, do we agree? M equals 0, still parallel. Alex, what's your name?
Joel.
Joel. Joel did make a good point. Could be the same line. I agree. So you have two lines, one on top of the other, still m equals 0, but it could be this also. The last one is going this way, another that way. I got myself a point of intersection. Okay. So this is the case that's important in business, going along the same lines. First application. No questions in this? Yes.
One's more positive.
One is more positive than other. We will get to that part soon. there are a few more options when we address that. But for now, are we clear with these? Okay. So I just have two lines and Powell. First side of analysis or application would be equilibrium. Some people like to call it economic equilibrium. The next case, break even. The last one. Oh. What does equilibrium mean? It's a mouthful, but what does it mean in simple terms? A balance, very good. So there has to be a balance between two things. In other words, there is a point where things become the same. Agreed? So by all means, I'm referring to about 5 minutes prior to this. What am I referring to in terms of two linear functions? The same. Both functions become the same at some point, the same slope. Same slope. The point of intersection, where one function meets the other, becomes exactly the same. So we are finding the point of intersection. What does break even mean?
Like term when it's like your profits and your revenue are like zero, so then you're like break even, your profits are zero, so you're like no loss for the profit.
So correct. So again, you are sort of reaching a balance. So you spent $100, you generated $100, you balanced, but you broke even, correct? You didn't go up, you didn't go down. So again, we are referring to points of intersection. Last case, cost analysis. This is a case where we don't specifically look at points of intersection, but we just want to know what the cost will be for a specific product, etc. Business makers, again, there are two types of costs. Do we know what they are? Variable and fixed. Okay. Forgot your name, but go ahead. What's your name? Andrew? Anthony. Okay. Eventually. So one is fixed, the other is variable. We do know the definition of fixed and variable, right? I would hope so. But what does it mean in terms of cost analysis?
Your fixed costs are set in stone. You have to pay no matter what. Variable costs are things that you could do, but like if you don't want to, you don't have to.
Okay, I can go with that. George, correct?
Geo.
Huh?
Geo.
Close. You got the G part right. G-E.
Variable costs increase with the amount of produce.
Very good. Your name? Ben. So Ben said, well, Geo has said, well, you can change it with something when you want to, or just let it be. Right? And Ben suggested, well, it is going to depend on how many units of something you produce. Well, you keep producing, then you're changing something. You just said, I'm not going to produce, let's take a break in not producing, So that would go to Geo's definition. So fixed cost, variable cost. So this will depend on the number of units that you produce. It could be other things. Also, it has another name. Starts with the letter M.
Marginal cost.
Marginal. So, do we have our calculator? It's a rabbit. Go ahead, start your calculator and hit y equals the top left corner, or is it top right corner? What do we see? Easy question. We see something? Yes. What do we see?
What's your
Y variables. Okay, so we are going to get to the calculator because one of the parts wants us to do something. If you press Y equals, you see a bunch of stuff. And if you look at those fields that are right in the calculator, we have Y's. I don't see any Y here. So the very first step should be to identify what is Y and what is X. They have made it easy for you in this problem if you have to guess what is Y. What letter matches Y? P. X. Q. So P is the price per pound and Q is the quantity in thousands of pounds of sugar. Price per pound and quantity in thousands. Does it make sense that they have to be balanced somehow? Okay, so we have identified Y, X. Earlier, I wrote S of X, T of X. This is exactly what I was referring to. So in your calculator, all you have to do if you used it before, not a big deal, but this is for people who have not used this calculator before. So first equation, Y, 1.4, split by X. X is right here, minus 0.6. First linear function. Second, minus 2. X plus 3.2. Enter, graph. One of the functions has a positive slope, the other negative. This is the case that I was referring to. Does it have a point of intersection? Yes. Do we know what that point of intersection is?
.1 as x and 0.96 y.
1.1 and
Well, it's like a big number.
it's a big number. Okay. So we have the technology, so we can directly use technology. So the algebraic way to get the solution would be to set supply equals demand. I'll show you how. It's my obligation. But let's find the answer using the calculator directly. So back to the calculator. I believe it is under second blue button, trace. Good. Do we see option 5 says intersect? Select option 5. What is it asking for?
So like the first one.
It's asking for the first curve, and then it's naturally going to ask for the second curve once you make the selection. So going to hit enter, first curve, enter again, second curve. Do we want to guess? Let's go ahead and guess. Enter, right in the middle. Good. So I have 1.12 for x. So we have x, we have y. So when supply meets demand, then we are in balance. So what quantity of sugar will result in that equilibrium point? Yes.
1.2 Q.
Come again?
1.2.
1.22.
1.2 Q.
No, I can't hear you.
1.2 Q.
1.1 to 1.118. Rounded value. I have it for 3 decimal places. So 1.118. And what is the corresponding demand? Is it? It's there. It's there.
0.965.
0.965. So all I did is simply found the point of intersection using the calculator, and then using which I can go for inferring whatever the calculator is giving us. So that is the calculator approach of doing things. Naturally, if a calculator can't do it, so can we. We had P, which is a function of Q, and that value or equation we had the second one for demand, and we ended up having negative 2q plus 3.2. So what did the calculator do? The calculator wanted to find the point of intersection. Earlier, I mentioned that point of intersection would simply mean one equation equal to the other. So set those two equal to each other. So 1.4q minus 0.6 equals negative 2q plus 3.2. All we have to do is solve for q. Move that to this side, positive 2q. Move negative 0.6 to that side, positive 0.6. .4q equals 3.8. Divide by 3.4, and that's what I get. Put that number in the calculator. I'll bet my life it is going to be 1.118, or else my life would be meaningless. Is it? Yes. Okay. So I found the value of x, which is q. How would I find p? Come again.
Plug it in.
Plug it in where?
Either one. Either one.
Either one. Marina? No.
Sophie.
Sophie. Sophie says either one. Why? Why does it not matter which one I pick?
Because they're intersecting at the same point.
They intersect at the same point, so we have a point of intersection. So S, D, they're going to be the same at that value of Q. So whether you plug it in here or plug it in there, the answer will be the same. And what would that answer be?
0.965.
0.965. Do we get it? Okay, this is the simplest case of economic equilibrium. But do you think real life is that easy? No, absolutely not. So eventually when we see other functions, I'll show you different equations, but the process will remain the same. Good? Okay. Erase. So if things have to be in balance, you should know how to put this in words. What should the demand be? If everything has to go smoothly, what should the demand be? Or what should the supply be? Answer it right here. U P S B U 1.48 and 0.965. Okay, so that was our x value, and Q is nothing but the quantity in thousands. And that is the price. So if supply has to match demand, the price of sugar has to be how much? 0.965. So close to $1.97. So if you buy £3, then approximately. Good. Are we clear? Now. Corbyn earlier mentioned, well, there is yet another case where when I wrote for options, he suggested, well, there is another possibility. What if one line has a bigger slope than the other? So this is what he was referring to. First line, yes. Second line, do we have a point of intersection?
Yes.
Yes, absolutely. So mathematics, we encounter something like that. In business, you would see. Good. So this is why I thought I'd